Alright, this will be our last video about binary. Today we're going to talk about binary subtraction. And we're going to go back to some of the ideas we had in the videos from last week where we were doing it with the duplo blocks. Do you remember that? Okay, so let's just take a look at binary. Let's do four digit binary. 1, 0, 1, 1. Remember, this is the ones digit, the twos digit, the fours digit, and the eights digit. So what number in base 2 is 1, 0, 1, 1?
11.
Okay, how did you figure that out?
8 plus 2 plus 1 is 11.
8 plus 2 plus 1 is 11. Great. So this is the number 11 because it's 1 times 8 plus 0 times 4 plus 1 times 2 plus 1 times 1. And that is?
That is 11. And
we're going to subtract the number, how about 1, 0, 1 base 2. And what is the number 1, 0, 1 base 2?
5.
5, because it's 1 times 4, 0 times 2, 1 times 1, so this is 5. So we know what we should expect to get. 11 minus 5 is?
11 minus 5, expecting to get 6.
Expecting to get 6. So let's see what we get. Do you want me to do one first to remind you, and then you'll do one by yourself next? Okay. So we just subtract all the digits. 1 minus 1 is 0. 1 minus 0 is 1. 0 minus 1 is minus 1. And 1 minus 0, there's nothing here, so this is really 0, 1, 0, 1. 1 minus 0 is 1. And first of all, I mean, this doesn't make sense, right? Why?
We have a minus 1.
We have a minus 1. We're only allowed to use zeros and ones. But let's see if it gives us 6 anyway, just to see. Remember, this is the ones digit, the twos digit, the fours digit, and the eights digit. So this is 1 times 8, minus 1 times 4, so that's 8 minus 4.
8 minus 4 is 4.
Plus 1 times 2.
Which is 6.
6. Plus 0 times 1. Okay, so we did get 6. We just didn't get it in the right format. Now, when we were doing our binary subtraction with the duplo blocks, what did we do when we got a minus 1? Remember, those were the red blocks?
Yeah. Well, we did the same process for 2's, but reverse.
But reverse, right? We have to take a 1 from here. We have to turn this 8, 1 times 8, into 2 times 4. Okay? So this 1 8 is the same as 2 4s, right? So when we have the number 1 minus 1, 1, 0, we turn this 0, remember this is the 1s, 2s, 4s, 8s. We turn this 8 into 2 1s, and this is 2 4s, I mean. 0, we turn it into a 2, so we cross it out, turn it into a 2. What's 2 minus 1?
2 minus 1, 1.
1. 1, 0. Okay. And that's just by saying this 8 is the same as 2 4s. And now we get this, 0, 1, 1, 0. Now we were hoping we would get 6, right? So this is 0 times 8, 1 times 4, 0 times 8, 1 times 4, 1 times 2, 0 times 1, and that is?
6.
Because it's 4 plus 2, which is 6. Yay, 6. Okay, now are you ready to do one all by yourself? Okay. So here we go. How about 1, 1, 0, 1. Minus 1, 1, 1. Okay, so first of all, let's just see what this is so we can make sure if we get the right answer. 1s, 2s, 4s, and 8s.
So, this top number is 1 times 1, which is 1, plus 0 times 2, plus 1 times 4, plus 1 times 8.
Right.
So, 1 plus 4 plus 8, 1 plus 4 is 5, plus 8 is 13.
13, very good. Okay.
Now, 1 times 1, which is 1, and then 2, no, 1 times 2, and then 1 times 4, which is going to be 6.
6. So this is 13 minus 6, which is
7.
7. Okay, now let's see if we can get 7. Okay, go ahead. Show me what you do.
1 minus 1 is 0.
0.
And 0 minus 1 is minus 1.
Okay.
1 minus 1 is 0. 1 minus 0 is just 1. 1 minus 0 is 1.
Oh, huh. This isn't 6. It's 4 plus 2 plus 1, which is 6. This is 7. And 13 minus 7 is...
13 minus 7. 13 minus 7 is... Well, it's 1 less than the one we got before, so... It's going to be...
13 minus 7 is...
13 minus 7. 6.
6. Okay. Now let's see if we got 6 down here. We got 1 times 8 minus 1 times 2. So that's 8 minus 2, which is?
8 minus 2, which is 6.
Yay! Okay, so this is right, except for one problem. 1, 0 minus 1, 0 isn't a binary number. Okay? So this one's a little harder to fix. So all we have is an 8. We have 1 times 8. And we have minus 1 times 2. And we have to get rid of this 2. But we only have one procedure. What is the procedure?
The procedure we do it with 2's except it's reversed.
It's reversed, right. Okay, so what are we going to do here? We have the number 1, 0, minus 1, 0. What are we going to do with this 8 here? 1 times 8.
We're going to turn it into 2 4s.
We're going to turn it into 2 4s. Now, that's going to say 0, 2, minus 1, 0. Now, oh, this is even a worse binary number. Because now it has a 2 and a minus 1. But wait a minute. One thing we could check, since this is the 1s, 2s, 4s, and 8s, is that it's still equal to 6. It's 2 times 4 minus 1 times 2, which is 8 minus 2, which is 6. Okay, so we must still be okay, right? Must still be okay. All right, now, what are we going to do with one of these 4s?
One of these 4s we're going to add it on to the minus 1.
Okay, what does 4 equal?
4 equals...
How many 2s?
Equals 2 2s.
2 2s. 4 is 2 times 2, so we're going to take one of these 4s. Okay. So what happens when I take away one of the 4s? The 2 turns into a...
2 turns into 2 1s.
Well, no. I have 2 4s and I take away 1 4, so how many 4s am I left with?
You're left with 1 4.
1 4, right. So I got... And now my 1 4 that I took away is 2 2s. So I put it up here, and I get a 2 minus 1.
2 minus 1 is 1.
1 and 0. So I get 1 times 4 plus 1 times 2, which is?
6.
6. So that tells me that after all of that hard work, that 1 1 0 1 minus 1 1 1, all in base 2, is 1 1 0.
1 1 0?
1 1 0. 13 minus 7 is 6. This is 13. That's 7. And that's 6. How about that? Pretty neat, isn't it? Do you think we better do this one more time?
No.
Not today, but tomorrow, I mean. Just to make sure you got it?
Yeah.
Yeah? Okay. We'll do that. There's no rush. We're trying to just understand how this works. And it's a little complicated, right?
Yeah.
But it seems to work. When does that computers count? Do you think you could ever become a computer?
Maybe.
Maybe? And count in binary? Alright. Good job today, honey. High five.